In data mining, when we have a data set, we usually divide it into different parts for different purposes. So in this video, I'm going to talk about the trained data set, the test data set, and also there's something called cross-validation. The common practice is to divide the dataset 80% for training the model and 20% to test the model. So that's why it is called the trained dataset and the test dataset. These numbers are not exact. It means that if you have a very big dataset, let's say you have a dataset with 1,000,000 instances, probably you can use a lot more portion of that data set for training. Maybe you can say you use 99% of the data set to train the model and 1% of the data set to test the model. That's okay if you have a very large number of data in your data set. But usually 80-20 or 90-10 is useful when you have a smaller data set, let's say 1,000 data. Okay. So now the question is why we don't use 100% of our data that we have for training the model. Well, the answer is that we would like to avoid something that is called overfitting. Overfitting means that the model learns too specifically into all the particulars in the dataset such that it will not generalize well to the new data that we see. Remember, in data mining, one of the important thing or the main purpose of building the model is that we would like to see when we have a new data that we have not seen in the future, we would like to use the model that we built to do prediction or classification for that new data. That's why we shouldn't use all the data that we have to build the model, because the model will overfit, will try to learn all the specific things that we have in the data set, such that when we show a new data, an unseen data to the model, then it will not perform well in that case. Now let's see an example of overfitting in the context of preparing yourself for an exam. Suppose your professor gives you all the previous exams and all the answers, and then when you prepare yourself to study, you get carried away, and it says here you spend all your time memorizing the model answers to all past questions. Okay, so if this is the case, then if the exam asks you exactly the same questions, then obviously you will do well. But most of the times, obviously the exam will ask different questions, although it's about the same topics, but the questions usually are different. Okay, if you studying by memorizing all the questions and the answers to the past exams, of course, you will be ill prepared and get a much lower mark than with a more traditional preparation. You know, learning all the concepts, understanding all the important things, and you can generalize it to the new questions that you have not seen. Okay, in the case that you memorize all the model answers to the past questions, then we can say that you were overfitting the past exam papers, and then the knowledge that you gained did not generalize to the future exam questions that you have not seen before the exam time. Okay. Now, as I've said before, we divide the data set into trained data set and test data set. The trained data set is used to build the model, to let the model learn the pattern from the data in that trained data set. Okay. Now, the remaining test data set is used to evaluate the model's performance independently. It means that this test data set must not be used for training the model, which is obvious. And also it must not be used to select a model's parameters. For example, if we use the model a decision tree, it means that we cannot use the test data set to select whether we should have this tree with the depth equal 3 or a tree the depth equals just 2, or a tree with the depth, let's say 4, 5, 6, and so on. We cannot use the data set to select that kind of parameters. Also, if you have a lot of different data mining model, and then you want to compare which model is the best from all the models that you compare, you cannot use the test data set as well. Okay, so the test data set can only be used when you already finish learning everything and you say that, okay, this is your best model with the best parameter, and then you test that model using the test data set. For what purpose? For describing the performance of the model that you have when it faces the unseen data, the new data in the future that will appear. Okay. Remember once more that all the data mining models that we've built has the purpose of helping us in the future when we see a new data that we have not seen at this moment. Okay, so remember that the test data set must not be used during the training, must not be used to select the model's parameter, must not be used to select which model is better among a lot of data mining models. Now you might wonder, if we cannot use the test dataset, then how are we supposed to select the model parameters or to compare between one data mining model and the other model if we cannot use the test dataset to do that? Well, the answer is somehow we need to use the trained dataset that we have. So we go back to the trained dataset that we have at the beginning, and then here comes the term cross-validation. So it means that if we have this data set, let's say 80% of the entire data, and then we will cut the data into several pieces. Okay, it's called the k-fold cross-validation. In this example, I use k equals 5. So it means that I'm dividing the training data set into 5 equal portions of data. Okay, and then remember when you choose the K, try to choose the K such that each fold of this cross-validation fold has at least 30 instances. Okay, so cross-validation, the first step of doing it is that we divide the data into K equal portions. Why are we doing this? Well, the main purpose is it will help us in selecting the model parameters or selecting which model is best among a lot of models. Okay. Next, I'm going to talk about how dividing this data into K folds will help us to select the parameters of a decision tree model. Now let's suppose we are going to compare the decision tree with the depth equals 2, and later we will have another decision tree with the depth equals 3. We will use the cross-validation, and here let's assume like before I have the 5-fold cross-validation. So I divide the training data set into 5 equal portions. So I will have k equals 1, k equals up to k equals 5. In the first fold of the data, I will use these 4 portions to build the decision tree. For the second fold, I will use this part and this remaining 3 part to build a decision tree. For the third fold, again, I use this 2 first part and the last 2 parts to build a decision tree. The fourth fold also similar, and the fifth fold I use the first 4 portions to build a decision tree. So here I have 5 decision tree, which is built using the 4 parts of each fold. Okay, the trees should be quite similar, but they can be different one another because you can see that we use different parts of the trained data to build the model. Okay. Now, what is the use of this test portion here that I use a quote symbol? Well, we will use it to test the tree that we built. Okay. So we use this 4 portion to build the tree. and then we use this test portion to test the performance of the tree. So for the first fold, using this part here, I get the accuracy of the decision tree for the first fold. For the second fold, I test the tree using this portion of the data. I get the accuracy for the second fold. And then for the third fold, I use this part to test the tree. For the fourth, I use this part. And then for the fifth, I use this part. Okay, so using just one trained data set, now I have 5 accuracy values. Okay, these values, we may take the average of them such that this will describe the performance of a tree with the depth equals 2. Now for the decision tree with the depth equals 3, we just repeat the same procedure, okay? So use this portion to build the tree, and then same for all other folds, and then use the yellow portion to measure the performance of the tree. Let's say we're using the accuracy, and then we take the average accuracy for depth equals 3, and then we compare it with the average accuracy from the tree with the depth equals 2 that we obtained from the previous slide. Okay. Now you may wonder why we use this yellow portions from each fold to test the tree that we built. Well, in this case, because we cannot use the real test data set that we keep until the end of when the model has been selected. So we pretend that we only have this part to train the model, and then we pretend, okay, this is the unseen data that we are going to see in the future. Okay, so we train the data using the using this part, and then we say, suppose this is the unseen data, this is the performance. And then we repeat for the second fold. Suppose we can only see this, and then we test it with that unseen data. This is the performance, and so on. Why do we need to change the portion that we use to test the data set? Well, maybe let's say this part is kind of more difficult in the data set to learn. So the performance will be bad if we only use that part. Or maybe this part of the data set is somewhat easier for the model to learn. Then if we only use this part to test the tree, then maybe our performance will be very good. So it will not give a fair description of how our model will perform. So that's why we take a different portion of the trained data and make it as if it is a test data set. Okay. So this is how we use the cross-validation process to select the parameters for the model, or you can also use this process to select different data mining model. Okay, so that's the end of this video. So you have learned how to divide a data set into trained data set, test data set, and then you use the training data set to perform cross-validation. Thank you.